All right, so for this next tab, we're going to talk about special products. And the one we're going to really focus on is this first one. And this first one, I'm just going to add a little note here. It's called difference of squares. Perfect squares, but we use to say squares as just abbreviation. Difference of perfect squares. All right, and the key thing is the reason why it's different is that you must see subtraction for it to be a difference of perfect squares. So right here, the minute I see here, so okay, must see subtraction. In order to do this little shortcut. Sorry about that. Go back again. Ah, dang it. I meant to fix this because I spelled that wrong. All right, so the rule is if I see a perfect square, a number raised to the power of 2, another number or term or variable raised to the power of 2, then the shortcut is your factor form would be a minus b and then a plus b. And the key to this is you have to take the square root, which is this symbol right here, sorry, of each term, okay? And I'll show you how we're going to break this down on number 13 here. So what you want to do is make sure each part of the term is a perfect square. So like if I start with just the coefficient and I do the square root of 9, and if you're not too sure, you can always put it in the calculator. And if it comes out, like if you do second x squared, and it comes out to be a whole number answer, then it's a perfect square. If you do second x squared, and let's say you get a decimal answer, it's not a perfect square. So you cannot do this shortcut, okay? So the square root of 9 is 3. The square root, if I go to my variable, of x squared is just x, okay? And then I have the second term, which is the square root of 16. And the square root of 16, it is also a perfect square, it's 4. So if I'm taking the square root and I put this all together, my factors here, this would equal 3x minus 4 and 3x, oops, sorry, and 3x plus 4. Like that, okay? And if I'm solving this, I would have to have it equal to 0. So I'm basically solving each factor form. Remember, this is your factor form right here. Making this, each of these equal to 0. And I am going to show a shortcut. Okay. So if I did that, that would mean, fix this. All right, let's factor form. That would mean that this 3x minus 4 would equal to 0. And the 3x plus 4 equals to 0. And so we're solving each for x, so you would have to add 4. Okay. That gives us 3x equals 4. And then you have to divide by 3. Okay, here you subtract 4. It gives 3x minus 4. And then you divide by 3. So when you simplify it, I'm just going to come up to the side here. Just cancel. You're going to get x equals 1 is a positive answer of 4/3. And the other one is a negative answer of 4/3. Oops. I put my bracket. All right, so the difference in squares, if I want my factor form, then I want to do this shortcut. Okay. But if I want to solve it, I can show you another way to get to your solution that's faster than looking at your factor form. So like what I tend to do is first I always check, is there a subtraction? Yes. Then what I do is I say, can I take the square root of the first term? Yep. That would turn into 5n. Can I take the square root of the second term? Yep. That square root of 81 would be 9. So I have 5 minus 9, and then I would have 5n, plus 9. That's my factors. Now, there is a shortcut to solving, because if it's a difference of squares, all right, and I'm going to have to do that. I know my room is kind of small, so I'm just going to make a little side note over here. Because I'm solving and this is equal to 0, let's say I had, and I'm going to have to move this over just slightly. Okay, let's do it over, I guess right here. All right, so if I had 25n squared minus 81 equals 0. This subtraction is very important because if I want to get my variable isolated, so this first term isolated, because I have this subtraction, I can add the 81, so that's 81, sorry, to both sides, okay? And I'm going to get this term by itself, and that would give me 25n squared equals 81. Then, to get the n squared by itself, means I would just get rid of the coefficient. So that's divided by 25. Okay. And that would give me n squared equals 81 over 25. Anytime I get a variable squared, okay, to do the inverse of that exponent, you take the square root, which is what we did earlier over here with this x squared. So when I'm taking the square root of this whole fraction, basically I'm just taking the square root of the top, the denominator, and the numerator. Okay, square root of 81, square root of 25. These are perfect squares. So my n equals plus or minus. It's always, when you take the square root, you're going to always have a positive answer and a negative answer. That's the symbol to use, positive and negative. And this would be 9 over 5. Plus or minus 9 over 5. So like if I'm doing 15 and I want to do the factor form of this, well, 8 is not a perfect square. Neither is 18. But you always want to check for a GCF first. That's always our first step. And I look and I ask myself, can 8 go into 18? No, but do they have a common factor between both of them? Yeah, the GCF here is 2. So if I divide this by 2, this would actually give me the, I'll put it right here, 2 parentheses, this would be 4 minus 9g squared, okay? And now this is a perfect square, number 4, the square root of 4, and this is also a perfect square. So this would end up being 2 minus 3g and 2 plus 3g. And that would be the factor form, okay? If I solve each form, which is this, I'll just need to make it equal to 0 and solve for g. If I wanted to solve just for the variable, okay, and I know I'm kind of running out of room here, so I'm going to have to extend this page a little bit. I would take this, the 2 doesn't matter, that's just my GCF in front. And I have my 4 minus 9g squared equal to 0. I'm going to take this factor, make it equal to 0, and solve for g. By doing that, I'm trying to get this 9g squared by itself. So I have to subtract 4. Subtract 4. This would give me negative 9g squared equals negative 4. Then I would need to get the g squared by itself by dividing by negative 9. Now, this is great because a negative divided by a negative is going to make that positive. So g squared equals 4/9. And now I just take the square root. So my g would equal a positive or negative plus or minus 2/3. Okay, which is the same thing if I would have did the factor form. All right, so that's the top part. That's the only one we really need to know, like I will talk about this shortcut, but this shortcut is when we have perfect square trinomials. But the beauty about this, if you don't understand how to do it, it goes right back to doing trinomials. If you can do a trinomial, if you can solve that one, then you can still do this, okay? You don't necessarily need the shortcut or understand how to do the shortcut. Let me fix this. To do that, bring that down. All right. So don't worry about 16 through 19 right now. And it's not really like a lot of questions. There's not a lot of questions like this on the star because you can solve it a different way. All right. So just take care of that for me, and we'll talk about the next tab next.